Hello, everyone. Welcome to this webinar. We're very excited to present about SpotInst and the way in which we assist with automation and optimization of cloud infrastructure. Before we kick off, I'd love to pass the mic, as it were, to Boyd from AWS, who is gladly going to assist with an introduction. Boyd, to you, sir.
Thank you very much. I'm very excited to be here today, and thank you everyone for joining us. My name is Boyd McGeechy. I'm a business development manager over in the Spot team for AWS. I've been working with Spot instances for the last 5 years across business development, product management, and just general management roles. And in that time, I've had the privilege to work with SpotInst and actually meet a lot of customers that have used SpotInst technology. So I'm really excited for them to share a little bit more today about how they make adoption of Spot so much easier and take sort of all of the time and energy that you might spend thinking and managing Spot instances out of your hands and just automate that for a whole host of different workloads. They really make it very easy, and I can attest that in the 5 years that I've been working on Spot, and in particular the last 3 years that I've been working closely with SpotInst, I have met a lot of very happy customers. So a little bit about Spot instances before I pass it over to Drew to take it away here. So hopefully most of you are aware of Spot instances, and that's probably why you've joined the call. But just very quickly, what are they? Spot instances are truly our spare EC2 capacity. To deliver the elasticity that customers expect from our products, it is necessary that we keep spare capacity available. And so what we're able to do is offer that spare capacity to customers, and 70 to 90% discounts over the prices of on demand, with the one caveat that is, because it's our spare capacity, if we need it back, we give you a 2-minute warning and we take that instance back off you. And I know SpotInst will probably talk about some of the additional functionality they offer on top of that. And one of the big things about Spot instance is, while it is our spare, the way that we encourage most customers to take advantage of Spot, and particularly if you want to use it for production type workloads, is enabling instance flexibility. Because while we do run out of spare capacity for a specific instance or a specific size in a specific zone around the world every now and then, we've never run out of Spot, never in a single AZ anywhere in the world. And so again, that's something that SpotInst helps automate and take all of the work out of your hands in a lot of cases to help you follow what we call Spot best practices, so that you can consistently run on Spot, consistently save money. And so with that, I'll hand over to Drew, and I'll just say I'll be hanging around today and answering questions toward the end when we have time for Q&A. So again, I'll just hand over to Drew, and thank you all for attending. Really excited to stick around and hear any of the questions that you have.
Boyd, thank you. This is Drew Reburn, everybody. I actually know Boyd from the 4 years I spent working at Amazon Web Services before I was at SpotInst, so it's good to certainly talk with you again. What I want to do is give a brief overview of SpotInst as a company before we talk about some of the specific things that we do to help automate your Spot workloads inside of AWS. So if you can look at the slide here, we were actually founded in 2015 in Tel Aviv. So our founders we're an Israeli company, but our headquarters in the United States is here in San Francisco, where I sit today. And we've raised about $60 million in venture capital funding, and we have over 150 employees globally. We have over 1,500 customers at this stage, helping them all automate their Spot workloads. So our growth in the demand that we've seen on the platform has been pretty dramatic. As far as AWS partnership is concerned, we are an advanced tech partner right now, which is the second highest tier that you can have as an AWS partner. And so we're extremely happy to talk to you about some of the things that we can do today to help you run these Spot workloads. I also want to call out very quickly that among those 1,500 customers, we have some of the largest enterprises in the world deploying Spot instances with us today. When I think about companies like Sony, when I think about VMware, some of these other companies that we've got on here, Ticketmaster is one of our customers that saved over $3 million with us last year off of their EC2 costs. So the adoption we've seen has not just been with small companies running small workloads. Instead, we've seen major enterprise adoption, which I think is relevant for a lot of the folks on the phone today. So I want to talk briefly about what this company does. We often tell people that we are a SaaS platform for DevOps automation, but really our killer feature is the way that we help you manage Spot instances, and hence the name of our company, SpotInst. Boyd gave a great overview of how spot instances are terrific for workloads that can tolerate interruption because of the 2-minute warning you get before the instances disappear. What we have built to help with that is a prediction algorithm that anticipates interruptions 15 to 20 minutes in advance. And when we do anticipate those interruptions, we will gracefully replace the interrupted instances inside of your AWS account with either spot instances elsewhere in your VPC in order to keep your costs low, or in the worst case scenario where there's no spot capacity available, we will fall back to on demand. It is this prediction algorithm and this replacement inside of your AWS account that allows us to offer a 99.99% uptime SLA. What this means is that it dramatically increases the scope of workloads that you can run on spot instances and capture those low costs and low prices. I want to talk about the 3 things that we do, I think, that are the really important things here. One is that we are great at working with containerized workloads because containers are so portable. They're an excellent fit for spot instances, and we've built autoscalers for both Kubernetes and ECS that enable us to listen to the compute requirements of the containers themselves and move them around on the instances that we gracefully replace. Another thing that we do really well is we work with applications that are already configured for auto-scaling groups. When you think about what Spotinst does, our Elastic group, which is our fundamental building block inside of your AWS account, in an architecture diagram would replace an auto-scaling group. And so that's the fundamental building block of what we do. Anything already configured for an auto-scaling group is a terrific fit for everything that we do. And then lastly, a lot of our customers that we talk to have already bought reserved instances, which is the main advice that Amazon Web Services will give you with respect to cost optimization. We help customers transition from reserved instances to the even less expensive spot instances in the following way. We will detect the vacant reserved instances inside of their AWS account. And then first we will spin up on-demand instances that match those vacant reserved instances in order to get you to 100% RI utilization. This is because a reserved instance that you've already committed to pay for is less expensive than a new spot instance. But when that reserved instance expires, a spot instance is the least expensive way to pay for EC2. So we will do the same graceful replacement of that on-demand instance with a spot instance that we would do in the case of a spot interruption. As a result, you can easily transition to using our service and using spot instances despite having reserved instances in your account today. That's a broad overview of what we do as a company. I'm going to transition it back to Grant Lee to do a quick MC here.
Thanks so much, Drew. That's a terrific overview. So just want to let the audience know that feel free to ask any questions you'd like over the chat, and we'll address them as we go. I'd love to pass the mic to Tomer Hadassy, who's one of our lead solution architects over here at Spotinst, for a more deep product overview. I know we have a practitioner-oriented audience here as well. You're looking to actually understand how this works and how you may use this yourself. So we'll do a product overview, and then we'll actually get to the fun stuff and look at the platform and understand how you may put this into action in your own environments. Thanks very much.
Thank you very much, Grant. So first off, I'll start with going a quick overview over the 2 main components that we use to orchestrate spot instances. The first is, as Drew mentioned, the Spotinst Elastic group. Elastic group is very similar in its nature to an auto-scaling group. We like to sometimes call it an auto-scaling group on steroids. Integrates into many different workloads and many different systems and gives you a native capability to use spot instances almost as a plug-and-play feature on any stateless workload that you have today, and stateful workloads as well. This helps you get that roughly 70 to 90% cost savings that spot instances offer, while guaranteeing 4 nines of SLA uptime for your workload given by Spotinst. Our second main product is Spotinst Ocean. Spotinst Ocean focuses on simplicity and automation around your containerized workloads. Ocean is another abstraction layer on top of Elastic Group that knows how to listen and monitor containerized applications like EKS, any type of Kubernetes, ECS, and more, in order to figure out what is the most efficient way to deploy infrastructure for your containers without you having to manage any of the overhead and while running everything on spot instances. With that, I think we'll jump into a demo. As Grant says, I think it's the best way to understand and experience a platform is simply to see it. And as we mentioned, feel free to ask any questions and we will address them as we go. Okay. So what we have in front of us is the Spotinst console. This is pretty much the landing page and the dashboard you get into when you start using Spotinst. The first thing you see is the number of running Spot instances in your account, the number of hours that they've been running for. That gives you the potential cost of what it would cost to run all these instance hours as on-demand machines. Then you see the actual Spot cost, which is what you have to pay or what you have paid to AWS to run these workloads. With that, we can derive the savings of about 66% for this environment, or about $320,000 over the last 30 days. The next thing we see here is the number of running on-demand servers, their hours and cost, and the RIs we help manage. We deliver a bit more dashboarding here. You can see your top activity, different ocean clusters in this case, your usage over time, spots and on-demand machines running. You can see your AWS resources just to get some better visibility into how you're deployed across the world and what's your balance between spot, on-demand, running instances, finding those long-lost EBS volumes that you're still paying for and not using. As Drew mentioned earlier, this is where you can see the normalized factor units of all your RIs and whether you're at 100% coverage or not. In case there's any delta in here, we will cover for it and make sure to utilize your existing reservations before we spin up any spot instances. And in a moment, I'll show you what you need to do to make it happen, which is click a checkbox. Right from here, I think it's best if we jump into the Elastic groups. But I think it's really great and important to see how easy it is to transition into an Elastic group. And how light the lift is to take an existing on-demand workload you have and move it into spot instances. For that, we'll jump into the spot in spot analyzer, which finds naturally stateless workloads in your account, then tells you how much you can save based on the current spot market prices for these workloads. From there, all you have to do is press this clone button. The Spotins will find the region and the name of the auto-scaling group that you're trying to take the configurations of. Press next. All of these configurations have now been imported. You can see them right here in plain English. They're also ready in a JSON in case you want to run this through a RESTful API. And not only that, we also build you a custom cloud formation with a Spotins custom resource that you can export and deploy right away wherever you want to get the exact same configuration you had for your auto-scaling group running on spot instances inside your own account in seconds. With that, we also give a Terraform. And we also support Ansible and a bunch of SDKs if needed. To get a better understanding of what Elastic Group is, I think it's great if we see what are the building blocks behind it. But quickly before we do that, here are some of the use cases that Elastic Group can support by default and right out of the box that within seconds can allow you to migrate from on-demand to spot instances or run a hybrid cluster of on-demand, spot, and reserved all together. These are classic web applications like anything that is auto-scaling today, anything sitting behind the load balancer or managed by Elastic Beanstalk or OpsWorks. It's CI/CD pipelines like code deploy managed instances and Chef managed instances, big data workloads like EMR, and of course, containerized applications, as we mentioned, any type of Kubernetes, ECS, Fargate, Batch, Docker Swarm, Rancher, Nomad, and Mesosphere. Lastly, Elastic Group also has the ability to manage stateful spot instances, persisting their data and network across spot interruptions. That's allowing you to use any legacy application or stateful workloads like Cassandra databases, Elasticsearch, Hadoop, and Kafka, while persisting all the data you have and maintaining the availability of your workload. That. Okay, with that, we'll jump into the configurations of a single Elastic Group to see what's happening inside of it. So we start with some basic settings, the name of the group and the region it's running in. Then we go to the capacity, see the target, the minimum and maximum the group can scale in. Next, we go into cluster orientation. You can choose the cluster orientation to help you orient our algorithms a bit better into how we run spot instances for you. If you choose availability, we'll lean more heavily towards capacity pools that have a lower rate of interruption according to the data that we've been collecting over the past 4 years. If you choose cost, we'll go towards higher rates of interruption, but some better savings. Balance will be a sweet spot in the middle, and the cheapest will simply be the market that currently has the best discount and the best priced instances for you. Next, you can choose your spot instances percentage. Instead of running the group, you don't have to necessarily run a group 100% on spot. In case you want to keep a fixed ratio as the group scales up and down, all you have to do is toggle this bar. Or if you want a fixed on-demand count to start with, all you have to do is choose how many instances that would be. So I mentioned earlier, in order to utilize your reservations, all you have to do is click this checkbox. Fallback to on-demand is another great feature that allows us to maintain your SLA, kind of a back to default mechanism. In case spot capacities are not available within the capacity pools you allow us to use, we'll fall back to on-demand. Another nice tweak you can find here is a built-in scheduler that can allow you to scale up and scale down or run automatic deployments whenever you'd like. With that, you can use all your dev environments running on spot instances during the day and getting shut down at night, and get very significant cost cutting, not only on the per hour EC2 cost, but by simply running EC2 for less time. Jumping into the compute tab, this is where we do most of the heavy lifting, and where you'll see a lot of the configurations you're probably already familiar with from AWS. So we start by choosing a VPC, a product, and the on-demand type of the instance we will fall back into if needed. Next, under availability zones, spot market scoring, and spot types, you can see a lot of the bread and butter of the Spotins platform. Like a traditional auto-scaling group, we choose one instance type and one availability zone, and hope to get capacity there. With Elastic Group, we encourage you to choose as many as makes sense for your application to work with those instances. With that, you can choose several instance types and sizes of several families, running across multiple availability zones. And then you'll see what we call a spot market scoring. Spot market scoring is a score generated by the Spotins platform based on a real-time view and historical data we have on the spot capacity pools and how they behave. It's a weighted score that calculates both the availability, the rate of interruption, the percentage of savings, both historically and in real time. The higher the score, the better the market is, and the better chances you have to get a lower rate of interruption. With that, we're able to achieve roughly a month of an average lifetime for a spot instance that we manage. And as you can see, the scores vary, and you can get the very same instance type, non-existent in one availability zone, performing pretty bad in another, performing somewhat better in another, and performing phenomenally well in others. With our data, you don't have to do anything about it. You simply need to choose the flexibility that makes sense for your application. And from then on, we will make these decisions for you in real time based on these capacity changes without you ever having to go back and manage it again. Next, we got our launch specifications. So your images, your security groups, your keepers, and your tags would all go in here. Every new instance that spins up will get all of them attached to it. Under additional configurations, so as I just mentioned, we encourage flexibility, and as Boyd mentioned in the beginning of our call, there will always be some spot capacity somewhere, and the more capacity pools you add, the better your chances are to always run on spot instances. However, you sometimes don't really feel comfortable with all that flexibility for all your workloads, and with that, we allow you to use preferred availability zones and preferred spot types. What will happen then is that the top tier of your instances will obviously be the vacant reservations if you allow us to use them. The second tier will be your preferred spot types and your preferred availability zones. Your third tier will be your non-preferred versions. Then your fourth tier will be, you will be fallback to on-demand machines, which would probably never be needed.
Just going to pause here for a second. This is terrific so far. I'm noticing some questions coming through. So at some point, can I use spot inst for AWS RDS instances too? Is one of the questions that's come up.
Unfortunately not. Spot instances are not available as a billing construct for RDS machines. And because of that, we are unable to manage them over there either.
Cool.
Anything else?
That's the only question I can see. So we can maybe see on the private chat here. Okay. No, so keep sending the questions on the main Q&A chat, and we'll receive them. So thanks very much. Okay.
So all classic EC2 machines are supported that are not sitting behind some type of managed service that masks them. So with that, anything that you do with the regular EC2s that you spin up of all instance types, sizes, and families in all regions, and as of this week, including GovCloud, now supports spot instances. RDS specifically doesn't. Okay. So moving on, we have some other AWS configurations you might want to associate with your machines, like IAM roles, public IPs, so forth. User data in your startup scripts, what usually kicks off your application will go right in here and will be triggered in every instance that joins the cluster. Shutdown script, in case anything needs to be gracefully shut down on the machines that are being replaced, we can also run a shutdown script in the machine. This is the only case where we need an agent to connect to your servers. It's an important time to mention. Spotist is a SaaS layer that connects to your existing AWS environment by assuming an IAM role and an IAM policy. It gives us no access to any of your data or to any personal or identifiable information inside your account. We do all of that by relying on the metadata available through AWS. Are SOC 2 compliant and have been working with many enterprises for many years now. Next, stateful. Stateful is another great feature for any legacy workloads, and as we mentioned, any kind of self-managed databases that you want to be running. With the stateful feature, Spotist is able to persist your root volumes, data volumes, and private network interfaces between spot interruptions. What we'll do is we'll take an initial snapshot of each one of the volumes, and then from then on, take continuous incremental snapshots every 5 minutes. With that, we're able to guarantee the consistency of your data. Using our prediction algorithm allows us more than enough time to take that one final snapshot when the instance is getting interrupted. The network interfaces will get fetched if necessary from the existing instance, and will be connected to the new one that we spin up. We obviously only maintain the last 3 snapshots to not create any excess costs of data. And it's all managed by us. All you have to do is simply click those checkboxes and let this be managed. To register your instances, to load balancers, target groups, or classic load balancers, you just choose them right in here. Auto healing, Spotist will also manage the auto healing of your instances, check the health checks, whether that's EC2, ELB, Kubernetes, or any other type of workload. Just to give you a quick sense of the ease of integration, let's say you have an ECS cluster and you want Spotist to help you manage it on Spot instances. All you have to do is choose the cluster name, choose auto scaling to be automatic, and that's it. You never have to manage infrastructure underneath ECS ever again. You can deploy whatever task and service. You can roll your cluster and manage updates in it. Spotist will do all of it for you while maintaining the SLA and getting you the most defragmented, cost-optimized cluster while leveraging instances of different life cycles, sizes, and families. Without you needing to do any code changes or any architectural changes to your application. This works the same pretty much with most of our integrations. They're all very light. Same thing for Kubernetes. You an in cluster and you deploy a controller. That controller feeds that metadata to us, and we're able to make all the scaling decisions in real time based on the application requirements. Pressing next. If this wasn't a containerized application, we're not using our container autoscaler. We obviously support the traditional simple scale up and scale down policies, as well as target scaling policies. And after that, we get back to this review tab. So we see this English summary of everything we just did, the cloud formation, and the Terraform as well. Can Spotist discover new auto-scaling groups and convert them to Spot at runtime? So first of all, if you have a new auto-scaling group that you're just deploying, you can deploy directly. You can deploy directly into Spotist as an Elastic group. Spotist is not a mechanism that is based on tags and will start deploying Spot instances into that same auto-scaling group. Take it once it's deployed, clone it, and we can send a scale down request once the new Elastic group is healthy and alive, and all instances have passed the health checks. A draining timeout will pass, and then we can send a draining and a scale down request to the existing auto-scaling group. Okay. From here, I'm going to jump into Ocean Cloud Clusters. As I mentioned earlier, Ocean is another abstraction layer on top of Elastic Group. Everything we saw that Elastic Group can do, Ocean can do as well, and better. Its main goal is to remove all your overhead and all your headaches for managing your Kubernetes instances, no matter how complex your Kubernetes setup is, how many different pods different versions, sizes, and requirements you have. Ocean will handle all of it for you. To quickly jump into it, just to give you a sense, we jump again into the configurations of Ocean just so you can see how it differs from Elastic Group. Like Elastic Group, you saw a lot of different configs. Start with some cluster details, the name, the identifier, and the region the cluster is running in. It's important to mention, this is not a managed Kubernetes service. This helps you wrap around any existing Kubernetes cluster you currently have, whether it's running in AWS through EKS or through KOps, whether you're running OpenShift or any other type of KubeSpray, KubeADM, or any other version you've deployed by yourself on the Amazon cloud, we can help you manage the underlying instances for. Pressing next. Again, we'll go into some configurations, the VPC and the subnets you're running in. With machine types, instead of choosing every single instance type you're interested in, you want to think about containers, you want to think about your resource requirements here. You will limit the instance families that you're allowing us to use. We're going to limit the resource sizes that you're allowing us to use. With that, we'll create the metrics and heat map of what's relevant for this cluster and choose the right instance at the right time whenever a new deployment or new containers are coming into the cluster. In some specifications, as we saw earlier, images, security groups, profiles, keepers, and user data. Tags all go right in here. And in self-limiting number of instances that of minimum and maximum capacity, you put the resource limitations on vCPUs and memory. That's how Kubernetes thinks about resources. And that's how we want to think about them too. And control some additional configurations. And that's pretty much it. That's all you have to do to configure the underlying infrastructure for your Kubernetes. From there, Ocean will read it in real time and respond accordingly. See what Ocean is and some of the other benefits it gives you. So first of all, it gives you very deep analytics and understanding of what's happening in your cluster, how it's scaling and why it's scaling at any given moment, the distribution of your instances across the world and the pods that are running in it. Another great feature in Ocean gives you a very detailed cost showback on how your Kubernetes cluster is accumulating costs per namespace and deployment. You see exactly how much you're paying as a portion of the overall cluster. You can get showbacks for 1 day, 7 days, or 30 days. And we can always pull more detailed reports if needed. Another great feature that Ocean offers is right sizing of your pods. So while doing all this bean packing and Tetris scaling of scaling the right instance at the right time based on the pod requirements is great, it's not super helpful if the pods are already oversized. With that, Ocean is monitoring all your pods and all your deployments to see if they're actually utilizing all the resources you've allocated for them. If they haven't, we're going to push resizing recommendations to help you redeploy your cluster and making sure that it's as optimized as it can be. Going forward, we see how everything here and all the controls are very pod-driven, very container-driven, thinking like Kubernetes about our infrastructure. So you can go to a namespace, see the deployments in it, press any given deployment, see the number of pods running, the requests in it, if there's any resizing recommendations, how it's been changing over time, all the labels and annotations associated, and the pods running inside the deployment itself. That we can go into any of the pods, kind of do the same thing. See the JSON configuration, what it's running, why it's running, what are the requests. And then you can press the host that it's running in, press the EC2 instance, and it will go right directly into your AWS console. In the meantime, you'll see the resource usage, how it's being spun up because of the memory requirements on the pod in this case, and what's running inside of it. Other great features in Ocean are cluster roles. Whenever an EKS image update comes out, Ocean can roll your cluster proactively, do all the draining, the replacement of the instances, the management of the version, and you don't have to do anything other than press actions and cluster roll. The log will give you very detailed information about how we're doing events and why they're happening. What instances are moving around, how many resources were in the cluster before that and after that, in case there wasn't an HPA scale down of your pods, but rather we're simply able to defragment the cluster by moving things around. We'll explain what the simulation was and how the pods were moving and where to. To manage scaling in Ocean, again, all you have to do, auto scaling is enabled, headroom configuration is automatic, and how aggressive can scale downs be. It's a good time to talk a bit about headroom. As I mentioned, we defragment your cluster constantly and spin up the right instance at the right time. However, spinning up an instance still takes about 90 seconds or so until it warms up and can actually take a pod into a running state. And we don't want to wait that long whenever a deployment happens. This is where headroom comes in. Headroom dynamically adjusts to every single one of your deployments to keep a few more units of work there that are identical to the most common pod size and to the most common deployment size in that cluster. What that gives us is that about 90-something% of the scaling events and the deployments happening in Kubernetes are immediately answered by the headroom, and we scale up more headroom for the next event. And then if an abnormal event comes, and let's say you're doing something in the financial market, it's 9:30 a.m., the market's open, and your clusters need to grow 10 times the size, Ocean will see that requirement coming, and in a single scaling event, we'll deploy as many instances as needed to answer all this requirement based on all the nodes, based on all the pods labels, annotations, affinities and anti-affinities, persistent volume claims, and so forth. You don't have to worry about any of that. You simply need to configure your pods according to how you want them to behave, and Ocean will configure your infrastructure accordingly as well. In case you're running a Kubernetes cluster that has more than one launch specifications and you need to run multiple auto-scaling groups underneath it, not for multiple instance types, but rather for multiple images and attributes, you don't have to manage more than one group. Obviously, Ocean will allow you all instance types and sizes in a single launch specification. So if your motivation was multiple sizes, you no longer need them. But if you need some GPU drives to help you run your AI and machine learning workloads, and you need a different image for that, all you have to do is add another launch spec here and add those details as seen in here. The last piece of Ocean is run workloads. You can run workloads directly through Ocean, either via this great UI or by giving it a YAML file that will deploy it. And you can see and manage all the deployments and how it's happening. Okay, so let's talk about a few of the questions. The first one is asking if, so for best results, do we recommend to use Elastic Group directly instead of plain ASG? The answer is yes. As I mentioned, the Elastic Group is kind of like an auto-scaling group on steroids. Anything you're doing today with your auto-scaling groups, Elastic Group will support, will be able to import. But on top of that, it's going to give you all this flexibility, monitoring, and understanding of what's happening in the cluster. And obviously, on top of that, it's going to give you our dedicated support and deep usage of data and analytics that we've gathered across pod capacity pools for many years now in order to make the decisions of what to deploy when. Does Ocean support ECS? So as I mentioned, Ocean is another abstraction layer on top of Elastic Group. So we can set up an Elastic Group today to work very similarly to Ocean. And Ocean will officially support ECS using, with all these analytics, with all this UI, everything driven by the ECS, obviously jargon and the way ECS thinks about workloads. In about 2 weeks, it will go into GA. And because of that, I cannot show an Ocean demo with ECS just yet.
So 2 weeks.
Yeah.
Okay. And then we have a couple more questions. So how do I connect Ocean to my Kubernetes cluster?
Yeah, that's a great question. So in order to connect your Spotinst to your Kubernetes cluster, Ocean to your Kubernetes cluster, all you have to do is take a small YAML file and deploy the controller that Spotinst uses. That controller will use the same cluster identifier we saw in the first step of the Ocean configuration. And you can probably see right in here. With that identifier, Ocean will basically know what to spin up and when and how. And that controller simply needs to be there. It requires almost no resources at all and knows how to self-manage itself in case of any failures and replacements to guarantee your cluster's uptime.
Great. And then another question is, does Spotinst have permissions to my AWS account?
So Spotinst has very light permissions into your account that only allow us to spin up resources. And even then, we only touch resources we've originally spun up and don't replace existing machines that you have. As I mentioned earlier, we have no access to any of your personal and user data, to any identifiable data in your account. We do not actually know what's running inside your Kubernetes cluster or inside your workloads. We simply see the metadata of these requirements.
Great. That's all the questions for now.
Okay, I guess we have a bit more time, so we can talk about a few other use cases and how we want to think about them. Okay, so I'll quickly talk a bit about how we would work with stateful clusters like Elasticsearch, and just to think about how that works. So when you have a quorum of data and you have a Cassandra or an Elasticsearch, and there are 3 instances sharing the same data in between them, they're actually able to handle an interruption as is and rebuild that data if you give them a 3rd node. The main issue with that is that the cluster starts spending almost all of its resources recovering lost data, which makes it really useless and also makes you have to scale it up more and simply actually pay more even though you're using spot instances. Without persistent stateful configurations, what you simply have to do is tell Elasticsearch to wait up every time it loses a node and wait about 7 minutes before it does shards reallocation. We need those 7 minutes. We will use the snapshots in the network interface to rebuild the machine, spin it back up again, connect it to Elasticsearch. Elasticsearch will ping that private IP and check what data it has on it. You'll see that it fits perfectly into the missing node in the quorum. And we simply understand that the node just restarted itself briefly. Might need to rebuild those last 5 minutes of data, but that will require almost no effort on the cluster. And with that, everything is managed by us. I see another question is how to create an Elastic group from inside your account. So once Spot is connected to your account and you deploy an Elastic group, it always deploys it into your account. Elastic group does not run in our environment, and we're not a cloud provider for you. We're a SaaS layer that always deploys it in your account. In case you want to deploy programmatically, you can use it. You can do it using the Spotinst APIs. You can also use our custom resource in CloudFormation and in Terraform, or use one of our SDKs. Another great use case is EMR clusters. With EMR, we have 2 different methods depending on how you use your EMR. Because these are short bursting clusters that are being deployed at the time of usage. We're able to deploy this entire cluster, including its masters, its core nodes, and its task nodes on Spot instances by using our decision making to figure out which ones will last the longest in order to let the cluster finish its job with no interruptions. Because you have a more ongoing long ETL pipeline, we can simply wrap around your existing EMR clusters in order to start managing all the task nodes on Spot instances, maintaining their availability, handling all the failovers, and creating new node pools if necessary, new instance groups, in order to maintain the uptime of your EMR cluster. Could we comment on pricing? Yes, definitely. I'll hand it back over to Drew to talk a bit how we price Spotinst.
Yeah, thank you, Tomer. So what we do is we charge 20% of the savings, and I'll talk through how we calculate this in just a moment when the data actually populates here. Essentially, we measure potential costs. So for the time period here, which is going to be month to date as this loads, we measure what the EC2 or EMR you used through our platform would have cost at the on-demand rate. Potential cost you can see is highlighted right here. The actual spot cost represents the dollar amount that you paid to Amazon because you were using Spot. So from those 2 numbers, we're able to derive a total saved and a savings percentage. Our fee is 20% of the total saved here. So in this case, let's say that the actual spot cost is 143,000 and total saved 20% of 268 is roughly 50,000. So we add 50,000, 55,000, let's say, onto the 143, and we get to about $198,000. This factors in our fee. In other words, you've cut your cost of EC2 by more than 50% just by using our platform with no upfront commitment at all. So unlike 3-year reserved instances or something like that, you're not committing to using a certain type of EC2 or committing for a certain time period with us. It's just 20% of the savings for the Spot workloads that we're running for you. I do want to mention with respect to pricing that when we run your reserved instances and we populate on-demand instances that match your vacant reserved instances, we charge nothing at all for that because we're not saving you money for spot. So it's just another feature that comes with our platform. Now, the last thing I would say about pricing is that whether you're using Elastigroup or whether you're using the augmented features that come with Ocean or any of our container management platforms, we don't charge anything extra for that either. It's still just the same 20% of spot savings.
And Drew, I know this question comes up often. Are there any other fees or charges beside the performance-based 20% of savings?
No, there are no other fees at all. So it is literally just the 20% of savings that we would charge.
And how is support handled?
So anybody who wants support from our platform just goes to the chat over here, 24/7, 365. You'll get a 2-minute human response time from one of our customer success engineers, and they're highly trained in the AWS platform and in Spotinst as well, and they'll be able to give good technical guidance for whatever problem you're having. So in the chat, you can just tell them to call you as well if you want phone support.
Couple of comments here from me on how you can access or start playing with this platform. So we do have a freemium model. So the first 20 instances are managed at no cost. We are available through the AWS Marketplace, and we'll also be sending an email with more information to everyone on the attendee list right after this webinar.
Yeah, I see another question here. I assume Spotinst runs 100% in AWS. How does Spotinst outage affect my deployments? So because all of your deployments are inside your own account, it doesn't really. All the instances will stay there and everything will be intact. It is important to mention we give you 4 nines of SLA on your workloads and on the Spotinst platform itself. 4 years to date, we have never had a downtime and have managed to keep ourselves up. If something does happen, we won't be there to recover any spot interruptions. But again, as I mentioned, because to begin we choose the spot instances with the highest rate of availability, the rate of interruption isn't really that high. And if this doomsday scenario does happen and we lose connection with your account or our systems are somehow down, there will be no immediate effect. It will give us more than enough leeway to recover whatever is happening. If the AWS itself is down, we are probably the least of your problems.
Perfect. So let's leave a little bit of time here to see if we have any other questions. We may end a touch early, but would love to leave last time here in the Q&A section to post any questions that you may have about how this platform works, how the savings model works, or how it reduces a lot of operational complexity. We're here to help. Well, I think we're on schedule. We'll wrap this up right at the 45-minute mark. I want to thank everyone for your time and attention today. More information coming, as well as the opportunity to test this out at no cost on a few instances, and then going forward, as Drew outlined, our pricing model is purely based on performance and specifically on cost-based performance. So we've really enjoyed this opportunity to connect. Boyd, any last thoughts on your end, sir?
No, thank you for taking the time, and yeah, just again, thank you everyone for joining us. Yeah, I'd encourage you, if you're not using Spot at all today, take Spotinst up on their offer to have a few instances running, paying absolutely nothing. There's nothing to lose there.
Fantastic. Thank you so much, everyone.